So I made this regeneratively cooled chamber demo to show off some of the other channel making methods. Uh, this is very rough. None of my sketches are really constrained here at all, and I pretty much guesstimated what everything looks like. So definitely don't take this with any type of uh, absoluteness about it. This is just kind of using a familiar shape of a regen chamber to show off how to route some more complicated channeling through a curved geometry. And I think there are some useful aspects of doing this type of demo because I included varying channel thickness or channel area, I guess, going through this chamber. Like it gets much thinner, kind of hard to see, but it gets much thinner by the throat and widens out as it goes through the nozzle. And it's also a triple pass, very arbitrarily made a triple pass. I just wanted to show off some more channel making stuff by making it a triple pass. But in this video, I'll show you through the process that I used and point out some of the problem areas that you might face if you try to do something similar. Because while I think I found a pretty good method for this, there are definitely issues with it and possible areas of improvement as well. All right, but let's get started here. I already have it made, of course. I'm going to mostly just be dropping through the timeline, and maybe I'll make a separate video where I recreate it from scratch, but obviously that'll be quite a bit longer than what this video is. But to start off, this is my base revolve. It's a sheet body for the chamber, and for the chamber, and also I included a little bit of the geometry for the volute. I didn't do anything fancy for the volute, like changing area, going around the nozzle exit. I just kept it simple. This wasn't really about the volute anyway, so. But one thing to note is I didn't close out this volute because otherwise it wouldn't let me revolve this as a sheet body. If I did that, it needs to be open at both ends to be sheet body compatible. But otherwise, this is just the outline for what the chamber will look like. And then I pretty quickly thickened it to make it into a solid body. I think I applied like 0.2 inches to it. But again, none of the dimensions really matter for this stuff. Okay, so then I knew that I wanted to create a surface that is placed within the middle of this thickness, which actually, if I jump down one more step, you can kind of see it there. I'm going to hide that revolve there. Yeah, see that little gray surface in the middle? That is used as a surface to create a curve from for the initial path that the channel will use. And the reason I have this plane here is to trim down that surface in the middle so that I don't have two curves. So if you ever use intersection curve to make curves from intersecting sheets or planes, if you have a set of curves or set of surfaces that intersect twice, it'll create two separate curves in the two places where it intersects, and I wanted to avoid that. And by doing a trim, which is just widen that to avoid that, I made this trim sheet that cuts down on this sheet body to be only so this is it originally. I cut it down to be just that, so that when I used this plane and I used this sheet, it created one curve instead of one here and then one on the other side. That just made my life a little bit easier going forward. Um, Very long way of explaining that. So after I got that part of it, I one thing I wanted to highlight before, the way I designed this chamber was very intentional. I left in a sharp curve without, or sharp corner without a smooth curve transition here, because that is like kind of an edge case that you need to address once you want to um, use your chamber profile to eventually be your path for the channeling. So I addressed that. Let me get rid of this trim sheet. I addressed that with adding in a little arc, and you can find the arcs from the curve tool, and you need to pretty much define a plane for that arc to operate on, and then it's almost like you're in a sketch. You just use a 3-point arc. You click on that line and then that line, set them tangent, and then define the radius. It's a pretty simple tool to use, especially if you want to avoid being in a sketch. So I made that arch to, I made that arch to clean up the geometry a little bit and avoid using this sharp cusp almost in this corner. And then you can't see it, but I trimmed out these two lines here to only allow that curvature in this curve that I'll eventually use to define part of the path for the channel. But trim curve is weird. I don't know why it does this, but it's always hard to change whether it's viewable or not. Sometimes it is, sometimes it isn't. Like, it doesn't show up after you apply it. You just have to trust that it worked sometimes. But imagine these two straight bits being, trimmed off. And then with that, I knew I wanted to do a triple pass with this Regen chamber, just to demonstrate some more complex stuff. So I used pattern geometry to pattern that intersection curve with the added little arch there 3 times, and I picked that was my parameter for the span angle. Very arbitrary again, but one thing to note here is I'm using pattern geometry instead of pattern feature. I typically like to use pattern geometry when I can because it tends to be a little lightweight, a little more lightweight compared to pattern feature. And I don't even, that's typically why I use it. Sometimes you have to use pattern feature though. This case doesn't really need to be lightweight since I'm only doing a 3 pattern, but regardless, after that I made another plane. I tend to define a lot of planes to help trim down stuff, and this plane is used to trim down the top parts of, that's our chamber, the top part of the chamber channel curves, specifically these two. I trim them down, and of course it isn't going to show it when I move on to where I do that operation, but I trim down these two lines at that plane to eventually make room for a nice curvature with which I make here with the bridge tool. The bridge tool is really cool. I think it's pretty useful and very versatile, and it's not something you need to enter a sketch for. You can just use the curve menu, and it's right there. You pretty much just click on the 2 lines you want to connect, and it will automatically make a curve to connect them that keeps tangent, keeps it to be tangent to both the initial curves you selected to connect, and you can adjust what those tangents look like by a shape control. And you can also, the part that makes it really useful for this case where we're having these these channels curve around a little bit to match to match the radius of our chamber is you can constrain this bend, this little bridge here, to a face. So I selected the trim down mid surface that I used to define the initial curve from as what this bridge should adhere itself to. So it's sticking to this curvature as it arches over, which otherwise it would just take the shortest path, which would intersect with this face here, which is not what we want. So it's a very cool tool. I recommend it when you ever need it. And I do the same thing at the bottom as well. This plane is a little bit out of where it should be, but it doesn't really matter for planes. But this plane is just used to trim off. Instead of these two curves, I trim off these two curves to add in another bridge using the same methodology of adhering it using constrained faces to the trim curve, the curve that goes through the thickness of the chamber that I used to define that this original curve profile. And then I used trim curve to trim out those two straight bits that extend past that bridge. Okay. So after that, we have 3 nice connected and continuous curves that we'll use for our eventual path for a channel. Now we have to define the profile of the channel, and that's pretty simply done as well. We just very small plane here. I'm gonna have to zoom in a ton. This plane is just I believe it's an on point, or no, it's an on curve plane. And if you are unaware, there's a ton of different ways you can define planes, and more likely than not, you can find one that works for you. There are 2 that work in this case, at least 2 that I know of. One of them is point and direction. You pretty much just point or click on the endpoint of this line and it'll populate that plane, but I did on curve for this one, which also works. So we define that plane at the end of this curve, and then I pretty basically just drew out a circle. I think it's like 0.1 inches in diameter. You might notice these 2 points. I might talk about them later. They were almost a debugging tool that I used later on, and we might end up talking about it, but used a circle as the profile for the channel. If you want it to be more fancy, you can maybe use a teardrop shape if it needed some overhang, but circle it is. And then I knew I wanted to have changing diameter or changing area of the channels going through the path. Earlier tests I did with this method without having a changing area kind of looked weird because you'd have to have really skinny channels throughout the entire thing to make them all fit in the throat area where the paths get a lot closer to each other, which I didn't think, it's not something you would probably design to be like that. I think typically you have changing channel areas for heat exchangers like this one. So I wanted to demonstrate that a little bit. So to do that, I'm going to define planes going throughout the length of this curve. And I'm going to hide. Ooh, man. I guess I'm not. I only define planes along one curve, and then I will eventually pattern them to the rest of the other 2 curves. So we're only going to follow one curve for now, but I'm defining planes at places where I anticipate a change in profile for the channel. So here's one of them. here's another, there's one, and then there's one at the end as well, right there. So at each location where these planes are, I'm changing the diameter of that initial circular profile for the channel. And um, and then I actually do add in the profiles for the channel. This one is just a projected curve from the one up here. I just drop it down using this straight line as a vector. You can also make it a sketch there. I think it's a little weird that I, out of the blue, used a project curve instead of just a typical sketch. Then I made another profile for the channel. This one is noticeably thinner as it gets closer to the throat. You can kind of see the difference. I made another one there, and the next plane profile, or sorry, the next plane location, and then I have the final one down here, which it goes back to a much wider channel width. So you get a varying channel diameter through the path, and I anticipated having, the same change in diameter as it goes up and down again, which is done by the pattern geometry, where I take the list of these different channel profiles, and I just pattern them through the other two paths. And then we really get into the more complicated stuff, and I had a doozy of a time trying to figure out a good way to complete this sweep from the top to bottom using this relatively complex curve guide. I guess not too complex, since it's only, it's on a plane, so it's not too complex, but having it change diameter was pretty hard to find a good way to do it. And I'm not entirely happy with this. This was just the best way I found, which was using a studio surface, although I'm pretty sure a sweep, just a simple swept tool command, would do the same job. The key was using the alignment by points, and really just trying to be careful about how you align it by points. When you initially make it with swept and circular profiles like this, it'll be all twisted up. It's very annoying. You pretty much have to hand sculpt this studio surface / swept to make it look the way you want. Realistically, it probably isn't going to be entirely dimensionally accurate, because if you're going in here, I'll do a little demo of what it was like. You have to grab these tan points and like move them around to, you can see I'm changing the shape of what it looks like between those two circular profiles. And sometimes you get these weird conditions where it's snapping to somewhere you don't want, and it messes everything up. So imagine that, but everything is all twisted up to start with, and you have to do it through the entire length of this channeling. It's a little bit annoying for sure. And it takes maybe, I don't know, probably took me like 5 minutes to do the whole thing, which isn't the worst, I guess, but it isn't ideal either, and you're probably getting a subpar product by the end of it. So if you have any better ideas, definitely let me know, because this can definitely be improved. So yeah, besides the point, or I guess part of the point. But to start, you just select each one of the circular channel profiles as you go down this path. Each one of these sections here, I can't expand it, but each one of these sections is another circuit. You can see the changing highlight there is another one of those circular profiles. And then the guide, I just used a single curve here, and just be carefully selecting the continuously defined curve that I wanted. And then another good point, the body type I used for this was sheet because I wanted to eventually use trim body to cut out the negative or essentially add in the channeling instead of a subtract. I found that using surfaces like this and using trim body tends to be a little lighter weight and has a bit quicker load time than just using subtract. You can have like multi-minute loads for using subtract if you're using complex stuff like this. So to keep it lightweight, I chose a surface here or a sheet surface body here. Can do it either way though, honestly. Okay, so that was definitely the hardest part and most tedious. In fact, it took me several hours to settle on using this tool. But yeah, it worked pretty well. Then after that, I um, patterned that sweep or that studio surface 3 more times. And you might be wondering to yourself, why did you bother? Why did you bother originally patterning those paths if you're just only doing one sweep and then patterning that's not the right word, but I'm rolling with it, the swept afterwards. And the real answer is I didn't really know what I was going to do, so I figured I'd need to pattern the paths, the curves 3 times just in case. So wasn't really a lot of forethought there, but eventually was needed. And then the next thing I did is, obviously these are 3 independent channels right now. They're not connected by these bridges that we made earlier, so I just added in a little swept that uses that bridge curve as the guide for adding in another surface. And then up here, is just a trim to bring down those sheet bodies from this one to be at the same level to take advantage of that bridge again, which is done there. We're kind of in the home stretch here. One thing I needed to do here is handle this little entryway to the channeling. Since if I go back here and show you what our volute looks like, I needed to find a way to get this sheet, to get this channel opening up in the volute. So I ended up using a sketch to do it. Oh, this is a different sketch actually. I'll go over this first. So this volute is still open. It has this gap in it that wasn't able to be defined when I originally made it to allow this to be a surface. So I needed to close that out here. And this was another thing I battled on a little bit because, man, I swear there should be a tool that is like extrude, but it, instead of extruding in one vector, it like contracts or something. Like there should be a tool that I grab this surface that wraps around the entire volute, like this little flat edge surface, and extend it inwards. It extends it inwards from all sides towards a central axis or something like that. I hunted around for a while. I didn't find anything. So I had to settle for creating a sketch like this where it bridges from the top surface here, extends it into this chamber wall, and then I revolved that around like so, goes 360 around, and then I thickened it and unioned it to the volute and to the chamber since they're the same body. So I followed those 3 steps, which it makes me so sad that I couldn't find a tool to do it a little bit cleaner. But this works. I'm not too unhappy with it. I added in an edge blend just to make it not have a really sharp internal corner, because, even though this is an imaginary part, stress concentrations were bugging me for that. Um, okay, anyway, uh, after that was done, I knew I wanted, I knew I needed to extend out this exit for the channel, because if you ever have a situation with a sheet, or really even two bodies that you plan on applying a Boolean operator to, like subtract, if you have a situation where they're intersecting each other at the same plane, like this one, where both the solid body here and the sheet body are being cut off at the same plane, you will have issues. There's a very common error called, I forget the name of it now, but it's something along the lines of intersection, or like bad intersection. Your two bodies or whatever have a point of zero thickness. You'll know it when you see it. It's very annoying, and it necessitates adding in a little bit extra length to whatever Boolean or whatever geometry you plan on using a Boolean to prevent areas where you have overlapping at the same plane. So in this case, I extended out this channel just to bring the top of the channel out from the top of this solid body. And I used extend sheet. It's a very good tool to do that. Very simple. Just click on the edge of your profile here and choose how far off it should go from that edge. Okay, so going back, now that I'm back to getting an entryway almost to our channel, turn off this clip section. Yeah, sure. So I need a way to get the fluid from this volute into this channel here. And right now it's, it's just straight down. It isn't, there's no connection point between the volute. Oh man, sorry for really bouncing around a lot with the display. I hope I've been told before that the way I handle CAD has made people nauseous, as like third-party watchers of me fooling around in CAD. I hope that isn't happening to you. If it is, I apologize. Anyway, I need to find a way to get fluid from the inside of this volute into this channel, and I do that with a sketch. It's going to be hard to see unless I hide that. I add in this sketch here, which I'll use as a guide for another sweep, and then that will, lead itself into the interior of this volute here. So there's a way to get fluid into the channeling. And then once I do that, I sew together all of the little bridges, all the little channel bridges, and this entryway, and all the other paths for our channel together, so I can use a trim body to, subtract from our solid chamber wall here. And then very simply, I just pattern that trim body feature. I know I said try to stay away from pattern feature. In this case, the trim body was a feature and it isn't really a geometry, so I just used pattern feature there and kind of got lazy a little bit. I'm sure there's a better way to do it. But that leaves us with our finalized in quotation marks, regen chamber. I'm pretty happy with it. If you look at, I did a little bit of tweaking, but if you look at the throat, really cool how it thins out towards the throat and then expands back towards the nozzle. It's a pretty cool piece to look at because there's so much going on. But yeah, it wasn't that many features looking back. and you can definitely find a way to cut it down even more. Um, and I hope this was somewhat informative and useful. You might be able to apply this type of modeling where you're using a lot of curves and surfaces to other things, but I find it especially useful for um, for cooling channels like this where you have a lot of winding paths. But anyway, hope that was useful. Let me know if you want a deeper dive going through step by step making something like this. I'd expect that video to be like an hour and a half long, though. But anyway, yeah, thanks for watching.